Thank you so much for that invitation. Let me proceed right away. So we know that there has been an explosion of flows toward ESG, and this audience doesn't need to know that. One thing that is also known, and just want to point out, is the fact that the ratings, when you look at them from very different ratings, they are all over the place. I call this the confetti plot, in the sense that when you actually look at the exact same company, exact same year, and you look at the ratings and you normalize them, maybe by the ranking of the common data, or when you put them normalized between 0 and 1, you get this data all over the place. And therefore, companies that can be on the top 10% for some rater might be on the bottom 10% for another rater. And in some sense, this creates complication when you are trying to decide how to construct a portfolio. So this paper is about using the fact that they are correlated across all of them, but they are noisy. So one way you can interpret this is that all these rating agencies are trying to make the same assessment to try to understand what is the impact that these companies have. And they are just proxies for that impact. They are all noisy measures, and that actually the returns depend on that impact, or that variable that we cannot observe, we're trying to proxy. This is almost like thinking that we have an ethical measure about the firms, and these are all proxies for that ethical behavior, that willingness to do something ethical or non-ethical. So what we're going to do is, in this paper, is we use an errors in variables approach. This will allow us to understand what part of that noise in the measurement can be used to estimate returns. This is very related to the previous paper. You see in the previous paper what they're doing, they're using ratings to create portfolios. This will tell you that because the measurements by themselves are noisy, you are assigning firms to one top portfolio that should not be in that one. And therefore, if we do that better, then those differences that were shown by Chris could be much, much larger. And in fact, I'm going to show you that the coefficients tend to be much, much larger for all the rating agencies. We're still finishing the paper, so we keep adding and adding rating agencies as we go along. So what we do here, we have 8 different rating agencies. So every time we get a rating agency, it takes a long time to actually match them, all of them across all the different categories that we have. The data comes from very different places. Some of them are from corporate social responsibility reports. A lot of them are from surveys. A lot of them are from the media. They have different proportions of these sources. And so, for example, you will have True Value Labs and Repris that are entirely based on media, and the ratings will change every single day. And you have the S&P Global, which used to be Robeco-san, that is very heavy on surveys. And so there are very different natures of the data. All of them are trying, in some sense, to make an assessment of the same thing, but they use very different data sources. So you would expect that the noises are different. So now they are correlated. I mean, not terribly correlated. This is something that this audience knows. So just some of them are actually negatively correlated, which is the example that I said before. But in some sense, there are some that actually are highly correlated. You will have between ISS and Vigeo, for example, correlations of 74%. But some of them will be actually negatively correlated. So Repris, that is based entirely on media and mostly bad news, they don't detect good things. So good claims of firms, they will not be detected, and therefore it's very truncated. So, and again, it is very valuable as a piece of information, but it's mostly on the negative realizations. So what we're going to do is we run a very simple regression. We're going to compute a stock returns on the left-hand side, and we're going to put the measurement of the rating agency on the right-hand side. We're going to estimate this with OLS, which will be the standard estimation, and then do an instrumental variable approach, which is what I will show you in a second. The idea of the instrumental variable approach is that I am correcting the noise of MSCI by looking at the correlation between MSCI and Sustainalytics, for example. That's the idea. And by the way, we have 8 rating agencies here, so we can do what is called over-identification test, and we can, by the way, we do that in the paper. I'm not going to show you everything here, but this captures not only what is the proper coefficient that you're estimating, but also will capture what is the size of the noise in each of the rating agencies. So you can rank them by noise. So this also allows you to construct indicators that are less that there's more agreement across all the rating agencies. And in fact, actually, after instrumentation, the agreement is very, very large. So, so this is more or less what happened to the coefficients. So these are, I'm showing you one of the tables, which is how much it increases the coefficient when you run this by rating agency and region of the world. It happens to be that actually the region of the world matters a lot. North America, Japan, and Europe, they behave completely different. So in fact, I mean, this is something that I didn't know exactly when we started, but by putting all this data together, we realized that there's tremendous difference about the response of the stock returns in those places to where they are in the world. So kind of the investors in Europe have been doing ESG for a long time. United States is expanding very fast, and Japan is kind of at the beginning. Maybe that explains these responses, but they are very, very different. But the interesting thing that we find is that every coefficient, doesn't matter where you estimate it, they tend to go up. In fact, I'm just showing you a subset here, but from something like 120 possible coefficients that we estimate, about 90% of them increase in absolute value. So they become much bigger. In other words, whatever impact that you were measuring is more important today. So in the regressions that were shown by Linda about materiality, if you were to run the exact same regressions, the impact will be higher than what you are estimating right now, because MSCI has some noise in the way they constructed the indexes. So this will allow us in some sense to think about, we have not done, but one of the things that I want to do is to think about what is the implicit noise in each of these rating agencies. And that will, in some sense, will tell me that maybe I should underweight those rating agencies that have higher degree of noise and put more weight on those that have smaller size of noise. These are the coefficients, so you have an idea. Again, this is some of the examples of the tables that we will have in the paper. This is a coefficient. I think I'm just showing you North America. Yes, I'm showing you only North America. So these are the coefficients for the different rating agencies. If you run a simple regression, 19 will be 19 basis points. So this is an improvement of 1 standard deviation for MSCI. And when you do the instrumentation, you can see that a lot of the coefficients become bigger. That's it. They become more significant and bigger when you put 7 ratings. This one, for example, here fails the over-identification restriction. So part of what we do in the paper is to understand which instruments are valid for which rating agencies. This is not, you cannot use everything at the same time. There are tests that you do, and we go in the paper to understand which of the rating agencies should be used to instrument for MSCI in North America. So which are the ones that truly correct for the noise versus the ones that don't correct for the noise. There are like the previous presentation, and I also a little bit of the discussion from the previous papers. We need to understand exactly why we're getting a positive returns here. We do get positive returns, and almost every theory. And Robert Stambaum just wrote a paper about it, and in fact, in our paper, we also have a model that finds exactly the same aspect, is that the expected returns should be actually be negative. We find a lot of positive. It could be the case that there are flows that are moving slowly with this, but we do need to find this. By the way, it could be related with other aspects like management quality, but we need to pay attention to these coefficients that we're getting all over the place. And by the way, not only we're getting positive, we're getting much bigger than typically. So in some sense, this puzzle is an important puzzle that we have to answer. So we don't answer here. So let me just
1 minute.
Yeah, I started the conclusion. You see, Joel, yeah, I have 12.5% of my blood is German. So, I finish exactly in 10 minutes. So in conclusion, what our paper does is there are standard estimates of the ESG's returns when you construct portfolios or you run regressions, either in expected terms and realized returns. They will suffer from attenuation bias. And the reason why they will suffer from that is that the measures that you put on the right-hand side are not the cause of the returns. the returns are not caused because you get a rating. Is that the rating is capturing something that is a fundamental aspect of the firms, and that fundamental, the rating is telling you that fundamental aspect is improving, and therefore the stock returns should be higher. Now, because these are all proxies of that fundamental aspect that we don't observe in my interpretation, is the ethical behavior of the firms. What we have to, the problems that happens when you run the regression, depending on the quality of the noise of that proxy, you will get different degrees of attenuations. So we can compute the noise signal ratio from every one of the raters and understand what is the attenuation variant that you're collecting. And in fact, the way we did it was to use a very simple technique that has been used for ages in econometrics, which is an instrumental variable approach where we think about one rating agency as an instrument for the other. We cannot use this in a disorganized manner. It is important that understand which rating agencies are instruments for whom. There are tests to do that, and that's what is described in the paper. I hope that this help us understand and construct better portfolios because implicitly we're going to be collecting that impact much better. Let me stop there. Thank you so much.